A black hole is a region of space-time where gravity is so strong that nothing, including light and other electromagnetic waves, is capable of possessing enough energy to escape it. Einstein's theory of general relativity predicts that a sufficiently compact mass can deform space-time to form a black hole. The boundary of no escape is called the event horizon. A black hole has a great effect on the fate and circumstances of an object crossing it, but it has no locally detectable features according to general relativity. In many ways, a black hole acts like an ideal black body, as it reflects no light. Quantum field theory in curved spacetime predicts that event horizons emit Hawking radiation with the same spectrum as a black body of a temperature inversely proportional to its mass. This temperature is of the order of billions of a Kelvin for stellar black holes, making it essentially impossible to observe directly. Once born, black holes can grow by accreting matter that falls into them, including gas stripped from neighboring stars and even other black holes. These gluttonous beasts are some of the most fascinating objects in space. The Milky Way could contain over 100 million black holes, though detecting these gluttonous beasts is very difficult. The first image of a black hole was captured in 2019 by the Event Horizon Telescope EHT collaboration. The striking photo of the black hole at the center of the M87 galaxy 55 million light-years from Earth thrilled scientists around the world. Black holes are expected to form via two distinct channels. According to the first pathway, they are stellar corpses, so they form when massive stars die. Stars whose birth masses are above roughly 8 to 10 times mass of our Sun. When they exhaust all their fuel, their hydrogen, they explode and die, leaving behind a very compact dense object, a black hole. The resulting black hole that is left behind is referred to as a stellar mass black hole, and its mass is of the order of a few times the mass of the Sun. Not all stars leave behind black holes. Stars with lower birth masses leave behind a neutron star or a white dwarf. Another way that black holes form is from the direct collapse of gas, a process that is expected to result in more massive black holes with a mass ranging from 1,000 times the mass of the Sun up to even 100,000 times the mass of the Sun. This channel circumvents the formation of the traditional star and is believed to operate in the early universe and produce more massive black hole seeds. A black hole 33 times the mass of the Sun is the largest stellar black hole ever spotted, and its strange companion star could help explain how it got so huge. Astronomers have found the largest stellar black hole ever spotted, dubbed Gaia BH3. It has a mass 33 times that of the Sun, dwarfed only by supermassive black holes and those that form through mergers of other black holes. No light can escape a black hole, so most of them are found by spotting the glow of the hot material orbiting them and falling in. However, BH3 is dormant, not devouring any material. Instead, the researchers found it by noticing the strange motion of a star that seemed to be orbiting a patch of empty space. This star itself is unusual too. It is made almost entirely of hydrogen and helium. Most stars contain at least some heavier elements, which formed in the hearts of massive stars and were distributed throughout space by supernova. But the first generations of stars would have had very low amounts of heavy elements. The composition of BH3's partner star suggests that the enormous star that eventually collapsed to form BH3 was also one of these primitive objects, which may have evolved differently from the way massive stars do today. This would explain how the black hole got so huge. Its size would be difficult to account for if it had evolved more like regular stars do. Finding such a massive black hole wasn't a complete surprise. Experiments that hunt for gravitational waves, which are ripples in space-time caused by the motions of heavy objects, have found signs of them in other galaxies. From these gravitational wave measurements, We should be expecting to see such black holes in our own galaxy, but we hadn't until now, and this should just be the beginning. The star is extremely bright, and generally, if you find something this bright, you expect to find many more fainter. Thank you for watching. If you've enjoyed our videos, subscribe to our channel, for there's more to come.